Alright, we're working on Intermediate Lesson 1, Basic Manipulations. Let's jump right into a problem. This is a multi-step percent problem. The sweet price of a sweet amigo, scratch that, a Bronco, is $5,832 before taxes. If the tax rate in Ohio is 7%, what is the total cost of the Bronco including taxes? A couple different ways you can do this. To find the tax, you take whatever you're spending on the item times the tax rate, which in this case is 7% or 7/100. That's going to give us $408.24. The question is, what is the total cost? So that would be the price of the vehicle plus the tax. To find that, we're going to add the price of the Bronco plus the tax, $408.24, and that's going to give us a total of $6,240.24. There's another way to do this problem, and that's if you understand that the original price represents 100% of the cost. In addition to that, you're going to be paying another 7%. So another way to do total cost would be to take the price of the vehicle and multiply it by 107%. The 100% comes from the total cost of the vehicle, the 7% comes from the tax. If you multiply those together, you're going to get the same dollar amount of $6,240.24. There we go. Number 2. Tom Sneaks offers a 20% discount on all Jordans during Black Friday. How much must Scotty Doesn't Know pay for Jordan 3s priced at $280? You can also do this in a couple different ways. One way would be to figure out what 20% discount is. So the discount is going to be the price of the item times 20%. And that is going to be $56. And then to find the sale price, we're going to take the original price minus the discount, and that's going to give us a price of $224. Once again, if you understand percentages, there's an alternate way to do this. If you're saving 20% of the cost, that means you're going to be paying 80%. So another way to do this problem, a different method, is to take the original price and multiply it by the percent that you are paying. This is very similar to the previous tax problem. The percent we're paying is 107%. Here we're paying 80%, which is 0.80 or 80 hundredths. And that's going to also give you $224. Next, let's talk about profit. Profit is taking the revenue, that's the money that comes into the company, minus the cost. Cost can be in many forms. Could be what you're paying the employees, could be from materials or whatever you're producing. So in general, profit is revenue minus cost. Example, an antique dealer bought a painting for $5,000. At what price should the dealer sell the painting in order to profit 60% of the cost of the painting? So you can do this once again in a couple different ways, and we don't actually use this formula for this problem. But if they bought it for $5,000 and they want to make 60% more than that, we're going to multiply that by 0.60, and that's going to give us $3,000. So 60% of 5,000 is $3,000. Well, when they're going to sell it, they want to sell it for the original money that they paid for it, plus the 60%, which is $3,000. It's going to give us $8,000 total. Another way to look at this problem, this is very similar to the first two that we did. They want to sell it at the original price, 160% of that. You want to get all your money back with 100% plus 60% more, and that's going to give you $8,000 as well. Let's look at some multi-step proportion problems. First of all, what is a proportion? Essentially, a proportion is setting two ratios equal to each other. So for example, I'll give you just a simple example. Let's say that 1 out of every 2 people in this classroom are girls. 1 out of 2 are girls. And let's say that there are 50 girls in the class. That must mean there are 100 students total. 1/2 is equivalent to 50 over 100. Another example, let's say that we had 9/27. That reduces to 1/3 as a proportion, two ratios that are equal to each other. Direct variation uses a proportion. Direct variation means that as one value gets bigger, the other one gets bigger. If one value gets smaller, the other one also gets smaller. Example, the number of items you buy, as that gets bigger, the amount of money that you spend is going to get larger. Another example, moving in the opposite direction, things getting smaller. The smaller your waist is, the smaller amount that you're going to weigh in general. So let's look at what the equation would be for direct variation. And it works like this. You're going to take the relationship that you have and divide them by each other. So relationship 1 is going to equal the relationship 2. Example. Find the cost of 4 donuts if a dozen donuts cost $3.60. Well, 1 dozen donuts, that's 12. 12 donuts cost $3.60. So find the cost, that's going to be on the bottom, of 4 donuts. This once again is direct variation. The relationship here is the cost for donuts. Relationship here is also cost for donuts. Across the top of these fractions, they're both donuts. Across the bottom, they're both going to be in dollars. So when you make a direct variation proportion, you need those relationships vertically and horizontally. To simplify this, we could multiply both sides of the equation, essentially cross-multiply. Multiply both sides of the equation by y and by 3.60. It's going to give us 12y equals 4 times 3.60. And then we could multiply 4 times 3.60, and we get 12y is 14.40. It's $14.40. And if we divide both sides by 12, we're going to get 1.2. Talking about money, so we should do decimal places. We get $1.20. That's one way to do this problem. Another way to do it is using a rate. And those chemistry-like conversions we did in a previous lesson. So if you look at the rate, it says a dozen donuts is $3.60. We're supposed to find the cost of 4 donuts. So we are essentially going to take 4 donuts, you can write it as a fraction if you want. We want to multiply it by something in the form of 1 so we can figure out what the cost is. Well, if we write this ratio, dozen donuts to $3.60 as a ratio, we want dozen on the bottom, so it cancels with the donuts on the top. And that is equivalent to $3.60. Now the units that we're in is in dollars. We'll do some more canceling here. We can divide both 4 and 12 by 4. So we end up with $3.60 divided by 3, and that once again is $1.20. You can do this problem in 2 different ways. They both work wonderfully, whichever way you're more comfortable with that you would want to do. Number 2 here, got a plane moving at a constant speed of 3,000 miles in 6 hours. How far will the plane fly in 8 hours? Once again, there's 2 different ways you can do this. If we write 3,000 miles over 6 hours, that fraction is equivalent to 1 because those are 2 equal things. Every 3,000 miles you get 6 hours. For every 6 hours you get 3,000 miles. How far will it fly in 8 hours? Well, if we multiply this by a fraction, we want the 8 to cancel, and the bottom is just going to be 1. So this is not equivalent to 1. This fraction here is not equivalent because our answer is not going to be equivalent to 1. So as far as canceling goes, we got hours on the top and bottom. We can also divide both 6 and 8 by 2. We can also divide 3 and 3,000 by 3. This ends up being 4,000. What units do we have left? We have miles left. So it's 4,000 miles. If you set this up as a proportion, you're going to get the same answer. Let me just show that real quick. It says that this plane is going 3,000 miles in 6 hours equals the difference between the proportion, you're setting things equal to each other, and in the conversion formulas you're multiplying a series of fractions where one of those fractions is not 1, but all the rest of them are. So we got miles on top, so we're going to have miles on top here, which we don't know how many miles that is. And then we have hours on the bottom. And then if you cross multiply here, or if you just multiply both sides by 8, and if I label that 8 when I bring it over, hours cancel, we're left with miles. If you put that in your calculator, you're going to also get 4,000 miles. So if both those ways make sense to you, pick whichever way is faster, because the ACT is all about speed. If a kickboxer can kick 320 heads in 5 minutes, how long will it take to kick 480 heads? So I'm going to once again just do this as a ratio and multiply it by a series of 1s, or 1, 1 in this case. We got 480 heads that need kicked. I'm going to write it as a fraction. I'm going to multiply this by a ratio that's equivalent to 1. 320 heads happens in 5 minutes. I want heads to cancel, so I have 320 on the bottom. It's important to label your numbers. We got 5 minutes on top. As far as canceling goes, heads cancel. You can do some division here to get this simpler, but you know what? What's the point? We want to save time. If you multiply 480 times 5 and then divide it by 320, .480 times 5 is 2,400. Divide that by 320, and you're going to get 7.5. It asks for minutes. How long will it take? It'll take 7.5 minutes. Number 4, if 20 butterflies weigh 25 ounces, how much do 15 butterflies weigh? So we're trying to figure out the weight of 15 flies made of butter. I'm going to multiply this by a ratio that's equivalent to 1. 20 butterflies weighs 25 ounces. I want the butter to cancel. That's going to go on the bottom. We've got 25 ounces on top. Butterflies cancel. If you put this in your calculator, multiply the top numbers and divide by the bottom, you get 18.75 ounces. There you go. So how this relationship works for inverse variation as one gets bigger, the other one gets smaller. When you have a relationship between two things, you multiply them together instead of dividing them. Example of an inverse relationship: the more hours I exercise, that number gets bigger. The less I'm going to weigh, that number is going to get smaller if I'm trying to do cardio. Or that's a good enough example. Let's look at example 1. A train trip from Cleveland to Denver takes 4 hours if the train travels 125 miles per hour. So the relationship here is that 4 hours at 125 miles per hour. So we are supposed to multiply things in a like relationship. So 125 miles per hour times 4 hours equals, how long will the trip last if the train travels 20 miles per hour? So we set it equal to 20 miles per hour times some unknown time. Well, if you multiply 125 times 4, you're going to get 500. Let's forget about the labels for now. Let's make it simpler. And if you divide both sides by 200, using the division property of equality for real numbers, you end up with 2.5 equals y. It says how long, so that's going to be measured in hours. 2.5 hours. Multi-step rate problems. 5 farmers consumed 120 chickens during a 4-hour meal. For the same chicken eating per farmer per hour, what would be the total cost of appetizers, consumed by 4 farmers during a 3-hour meal? So this is not we have to determine if this is direct or indirect relationship. And it's direct because the more time you have to eat, the more chickens you'll be able to eat. So those are moving in the same direction. So at the beginning here, we are told 120 chickens for a 4-hour meal, and then it tells us the relationship: chicken eaten per farmer per hour. So the chickens eaten is 120 chickens By the way, the word per means divided by, which means fraction. Per farmer, said there were 5 farmers. And then it says per hour, that happened in 4 hours. It's a complex fraction, no doubt. And the question is, what would be the total, it says total cost, it should say the total chickens. Typo, fire my secretary. So set this equal to, what would be the total cost, total number of chickens, so we don't know what that is, consumed by 4 farmers during a 3-hour meal. So we have this ridiculous complex fraction. The labels are really important to put on at the beginning so you understand how the relationships work. So how do you adjust a complex fraction so it's not complex? Well, there's a couple different ways to think about it. I always like to think about multiplying by 1. If I multiply something by 1, it does not change its value. So if I multiply this by 4 over 4, I'm multiplying this 4 times this, and this 4 times the bottom. Down on the bottom, 4 divided by 4 cancels. On the top, 4 times 120, that's going to be 480. So that's 480 over 5. If I do a similar thing over here, multiply the top and bottom by 3, I'm going to get 3x over 4, because those 3's will cancel. Then, trying to solve this equation, I could cross multiply both sides by 4 and 5. On the left, I'm going to get 480 times 4, which is 1920. On the right, I get 15x. And if I divide both sides by 15, I'm going to get 128. Question asked, what was the total chickens? It would be 128 chickens would be consumed. So let me go back to a point here that you may have found confusing, which was changing a complex fraction to not complex. So if you don't like what I just showed you, another way to look at this is, if you have a number like x divided by a fraction like 4 over 3, you can take the top and just multiply it by the reciprocal of the bottom, which is going to be 3x over 4. Same thing, different way to look at it. Distance, rate, and time. Distance equals rate times time. Rate is the speed, like miles per hour. Time would be hours in that case, and distance would be in miles. Kelly left Pioli to drive to Cincinnati at 6:15 p.m. and arrived at 11:45 p.m. Well, right now, I think I need to figure out how much time that was. So if I go from 11:45 as my end, and I'm starting at 6:15, and I subtract those, old school style, I end up with 5 hours, 30 minutes. So instead of being in hours and minutes, it's probably easier just to be in hours. So that's going to be 5.5 hours. So what that first sentence is telling us, this person traveled for 5.5 hours. He, Kelly's a boy, averaged 50 miles per hour while driving and stopped 1 hour to tip cows. How many miles is Pioli from Cincinnati? Well, the whole trip took 5.5 hours, but they stopped 1 hour for a little cow tipping. So that means the total time driven is actually 4.5 hours. Since distance equals rate times time, and our rate was 50 miles per hour, and our time was 4.5 hours, that means our distance is going to be, when you multiply those, 225 miles. Number 2, ODOT log recorded an average of 26 cars per hour passing through Gilmore over a 3-day period. At this rate, how many cars would pass through Gilmore in a 24-hour period? Well, we got 24 hours, and we want to figure out what that's going to be, how many cars that would be. This here is a rate. 3 days, you get 26. I'm sorry, that's not right. So this is the rate. 26 cars for every 3 hours. Pardon me, every 1 hour. So for every 1 hour, 26 cars are going to pass by. Once again, this fraction here is the same as 1. They are equivalent things. You can always multiply something by 1 and it will never change its value. So the hours cancel. So we got 24 times 26. That's 624 cars would pass through here in a 24-hour period. Okay, a couple more problems. During Project X, a student calculated the frequency of screams of 12.3 per square mile and the depth of the forest. Based upon this finding, how many screams should the student expect to hear in 20 square miles? So we got 20 square miles. We're going to multiply this by 1 in the form of a fraction. This is 12.3 screams per square mile. We want the miles to cancel. So we'll put the 12.3 screams on top. That cancels. You got 20 times 12.3, which is 246. That's a lot of screams, folks. It's a lot of screams. Last one, multi-step unit conversion. This is all about multiplying by ones once again. A horse travels at a constant rate of 35 miles per hour. Approximate how many kilometers the horse travels in 20 minutes. So we are trying to convert 20 minutes to kilometers. Well, there's a couple things that we know. We know this rate, 37 miles per hour, which would be written like this. We know this rate, which is 1 kilometer, is 0.62 miles. Now those two rates that I just wrote could be reciprocated. The top could be the bottom could be the top, and they're still equivalent. So we need to first get minutes as a time, but the time that we're trying to get, or the time frame that we're using, is in hours. So if we bring this and change minutes to hours, because we need to be in the same units, there are 60 minutes in 1 hour. So now we are in hours. That's great. Now we need to change this 37 miles per hour into miles. So right now we're in 20 hours. So we're going to multiply this. I want the hours to cancel. So we got 1 hour on the bottom. 37 miles on top. Now the hours cancel. Now I'm just straight up in miles. So I'm supposed to figure out how many kilometers I'm supposed to get. Well, I'm going to multiply it by this fraction here. I want the miles to cancel, so I'm going to put 0.62 miles on the bottom and 1 kilometer on top. Now I'm just straight up in kilometers. If you multiply the top numbers together, I'll do that real quick with a calculator, 20 times 37, you get 760 kilometers. Multiply the bottom numbers together, 60 times 0.62, you get 37.2. That has no label because they are all been canceled out. If you divide those, you're going to get approximately 20 kilometers. Sweet. Please do exercise set 1 of the intermediate